Hello and welcome to Get Going with Gradle, the fastest way to a working knowledge of Gradle. Before we get started, here's a quick overview of what to expect from this course and how to make the most of it. Who is this course for? This course is specifically for anyone in one of these scenarios. You have no Gradle knowledge and you want to get started fast. This course will help you get there. You might have used Gradle for a while but aren't confident making changes to a build. Or you know some Gradle but want to better understand the fundamentals before learning about more advanced topics. If any of these sounds like you, then you're in the right place. What will you learn? By the time you reach the end of this course, you'll understand when to use Gradle, have created your first Gradle project, be able to create a simple Java project in Gradle, understand the key aspects of a Gradle build script, and know how to write simple code in Kotlin, the Gradle scripting language. Ultimately, by the end, you'll be more confident and effective working with Gradle, with a solid foundation on which you can build in the future. Finally, here's some information about how you can make the most of this course. Some lessons are theoretical, where you just need to understand the concepts. Others are practical, where you'll get the most benefit by actually doing the steps yourself. You'll find full step-by-step instructions below each practical, and you can slow down or speed up videos as you like. That's everything you need to know before beginning this course. Now it's time to get going with Gradle. I look forward to seeing you in the next lesson, which is an introduction to Gradle. Welcome to this first lesson where you'll get a high-level overview of Gradle, including what it is, why you would use it, why it's so powerful, and what makes it better than other build tools. Let's get right into it. So first up, let's answer the question, what is Gradle? Primarily, it's a build automation tool. A build automation tool takes all the code in your project and packages it into a deployable unit that can be run in the target environment. Gradle can be used to build small or large projects. Gradle builds are written in Kotlin, a scripting language built on top of the Java Virtual Machine, JVM. You can also write Gradle build scripts using another JVM language called Groovy. In this course, we'll focus on the recommended Kotlin version. In later lessons, we'll look into a few important characteristics of Kotlin that enable you to properly understand Gradle build scripts. Finally, Gradle is highly configurable. That means that even if you have some obscure requirement in your build, you'll almost certainly find a way to do it in Gradle. Here are 4 compelling reasons why you would use Gradle. Gradle makes building and running applications very easy because it's specifically designed for this purpose. It's very likely that if you try to create a build mechanism yourself for your application from scratch, you'll waste a lot of time and end up with something not as performant and streamlined as you would with Gradle. There's no need for people using your projects to install Gradle. That's because the Gradle wrapper script, which we'll talk about later, comes bundled with Gradle projects. Just download a Git repository and run /gradlew-build to build the project. It's that simple. It's very concise and less verbose than tools like Maven because the build is defined in code and not XML. It's very performant and supports incremental builds, so you don't do the same things multiple times unnecessarily. For example, it won't rerun the same tests if the code hasn't changed. What are the key Gradle concepts? We'll cover each of these in more detail later, but here's a quick overview of the most important components of Gradle. Concept 1 is the build.gradle.kts file, which is your Gradle build script, where you define how your project is built. It's written in Kotlin and uses a Gradle domain-specific language, DSL, to make defining your build as concise as possible. All this means is that it uses some special Kotlin language features we'll cover later to keep things neat and tidy. If you've used Maven before, the build.gradle.kts file is equivalent to Maven's pom.xml file. Finally, before we get into an example, the build.gradle.kts lives at the top level of your project. It's time to jump into a simple Gradle build script example. Don't worry about understanding every detail for now, because we'll cover this again later on. Plugins are the main way for you to add more functionality to your build. Here we have the Java plugin, which adds capabilities like compiling Java code and running tests. You'll see exactly how this works later. Metadata, such as your project's group and version, are important to specify. They get used in different places in your build, like in the naming of artifacts, such as Java jar files. If you're wondering where the project name is specified, That's in a different file, settings.gradle.kts, which we'll explore later on. Repositories is where your build's dependencies are downloaded from. A very common repositories for Java projects is Maven Central, but Gradle also supports Google, and you could even specify your own private repository. Dependencies are artifacts that are required in order to build your project. During your build, Gradle downloads the dependencies from the specified repositories. Common examples include JUnit for running tests and Spring Boot for building web applications. The next key concept to understand is the Gradle task. A task defines a unit of work to be executed in your build. This could be anything from compiling your code to publishing it to a remote repository. You can invoke one or many tasks from the command line. Here's an example of running the build task, which compiles and tests a project. If you're wondering what the /gradlew means, that's just how you invoke Gradle. You'll learn more in a moment. You can see a list of available tasks in your project by running /gradlew space tasks, and you can create your own custom tasks if the functionality you need doesn't already exist. Tasks can have dependencies on other tasks. This means that the task which is depended on gets run first. All the dependencies between tasks in a project create what is called the Gradle task graph. Here's how some of the task graph looks for the build task. The build task depends on the assemble task, which packages the application, and the check task, which runs tests. The final key Gradle concept is the wrapper, which is a script which you use to invoke Gradle and run tasks. In the previous slide, we talked about the build task, but how do you run it? In Mac or Linux environments with /gradlew space build, in Windows environments with gradlew.bat space build. Importantly, the wrapper script is always committed into your project's version control system. This means when someone wants to build your project, they don't need to have Gradle installed on their machine. They just check out your project and build it. The Gradle wrapper also contains a specific version of Gradle. This avoids any incompatibility problems, since you know that your project's build works with the specified version. For these reasons, you should always use the Gradle wrapper script by running /gradlew or gradlew.bat. The only time you wouldn't use the Gradle wrapper is when you need to initialize a new Gradle project, which you can do using a local Gradle installation. We'll cover that in a practical later on. Before we complete this lesson, here are the key points to remember. Gradle is a modern customizable build automation tool. Gradle build scripts are written in the Kotlin programming language. The build script is contained in a build.gradle.kts file. The build script has plugins, metadata, repositories, and dependencies. Tasks in Gradle represent a unit of work and are linked together in the Gradle task graph. You run tasks using the Gradle wrapper script, checked into version control. See you in the next lesson. Welcome back. In this lesson, you'll install Gradle on your machine so it's ready to use in the rest of the course. Whether you're a Windows, Linux, or Mac user, I'll cover the steps you need to take. One important point, because Gradle runs in Java, you need the Java JDK installed. At the time of recording, Java 17 is the most recent long-term support version compatible with Gradle, and you'll find a download link in the notes below. Here's an overview of the steps we'll follow to install Gradle. First off, we'll validate that Java is installed properly. Second, we'll download Gradle and set it up in our environment. Finally, we'll validate that Gradle has been installed. I'll run through installation separately for Windows, then Linux environments. And if you're on a Mac, you can use the brew package manager to install Gradle, which I'll cover at the end. Follow along with these steps as I do them, or watch the full video, then complete the step-by-step instructions below. Let's start by installing Gradle on Windows. Start by validating your Java installation. Open a Windows command prompt and type java-version. It should print details of your current Java installation. Gradle works with versions 8 and above. Now it's time to download Gradle. Go to gradle.org/releases. Select the most recent Gradle release. At the time of recording, that was 8.4. Choose the binary only option and click the link. to download the zip file to your computer. You'll now create a Gradle directory on your hard drive and extract the zip file into that directory. Open File Explorer, navigate to your hard drive, and create a new folder. Call it Gradle. Then navigate to the zip file you just downloaded, right-click, extract all, and extract it to the new Gradle directory. You should now have a new directory in the Gradle directory. Go into that directory, then into bin, and copy the path from the address bar. Now we'll configure the path environment variables that you can run Gradle commands from wherever you are in the command prompt. Bring up the System Properties dialog, which you can do by typing environment variables into the Start menu. Click Environment Variables. Then under System Variables, double-click Path. And we'll add a new entry to Path and paste in the value you copied earlier. Hit OK, OK again, and OK again. Open a new Windows command prompt, and we'll validate the Gradle installation with Gradle -- version. You should see some output showing that a specific version of Gradle is installed. If you're a Windows user, well done, that's all you need to do before moving on to the next lesson. Now let's cover installing Gradle on Linux. I'll set this up in Ubuntu Linux, but these steps should be similar for other distributions. Within an Ubuntu terminal window, validate that Java is installed with Java -- version. It should print out details of your current Java installation. Gradle works with versions 8 and above. Download the latest version of Gradle using this curl command. Then unzip the file to opt/Gradle using this command. If prompted for your password, enter it because you're running this command as the root user. Look at the contents of the Gradle installation using the ls command. You should see some files and directories. Set up your path environment variable by adding this entry to the .bashrc file with this command. Now close the terminal and open a new one, and validate that Gradle has been successfully installed with Gradle -- version. You should see some output showing that a specific version of Gradle is installed. If you're a Linux user, well done, that's all you need to do before moving on to the next lesson. Finally, before we finish this lesson, here are some other installation options. If you're using a Mac, you can use the brew package manager to install Gradle. Just run brew install Gradle. If you're using the SDKman package manager, the command is SDK install Gradle, then the Gradle version. Whatever your environment, you should now have Gradle installed. See you in the next lesson. In this short lesson, you'll learn the basic structure of a Gradle project in preparation for building your first Gradle project in a later lesson. Before we get into the structure of a simple project, note that Gradle does support both single project and multi-project build structures. If you've used Maven before, you might be familiar with these concepts. A single project structure is normally what you use when you have a small project to build, which produces a single build output. A multi-project structure is used for a complex project, which is split into several distinct components, each of which may produce their own build outputs. In this introductory Gradle course, we'll explore the single project structure, which is more than sufficient for many real-world use cases. What you see here is the file structure of a simple single project Gradle build. In fact, the project is so simple that the only files here are related to Gradle itself. This allows us to really understand which files are Gradle specific before we start adding code to our project in later lessons. build.gradle.kts is the main file where we define how our Gradle build should work, including adding plugins, metadata, repositories, and dependencies. We'll cover it again in more detail in later lessons. The Gradle directory contains code and configuration for the Gradle wrapper. There are the Gradle wrapper scripts themselves, including GradleW for Linux and Mac environments, and GradleW.bat for Windows. These are both committed into version control, so your project can automatically be built in any environment without installing Gradle separately. The settings.gradle.kts file contains additional configuration for your project outside of the build.gradle.kts. Importantly, here you specify the project name, which gets used in various places, like in the naming of generated build artifacts. Importantly, all the files and directories from the previous slide should be committed into version control. There is one additional hidden directory, the .gradle directory, which should not go into version control. This is a project-specific cache used internally by Gradle. We don't need to know any more details other than that it should be added to your .gitignore file and not committed to version control. Fortunately, when you use Gradle to generate your project, it automatically generates the correct .gitignore file, but it's important to know what is and isn't stored in version control. See you in the next lesson. Welcome back. In this lesson, you're finally going to create a Gradle project and see with your own eyes why it's such an amazingly useful tool. This is another practical where you should complete the provided steps yourself. So what will we be doing? We'll use the Gradle installation you set up earlier to run the Gradle init command. This bootstraps a brand new Gradle project. The time to use Gradle init is when you're starting a new project or working with an existing project which doesn't use Gradle yet, and you want to automatically generate all the necessary Gradle build files. The Gradle init command comes with a setup wizard, which we'll run through to understand the different options. Once the project has been generated, we'll step through each of the new files and directories. Just like with a real project, we'll commit the project into version control using Git. And whether you're using Linux, Mac, or a Windows environment, you'll find step-by-step instructions below this video. Open up a terminal and navigate to your home directory. I'm in a Linux terminal here, but you can find the equivalent Windows commands in the notes below this video. Create a directory for the project called getgoingwithgradle, type mkdir getgoingwithgradle, and hit enter. Navigate into the directory with cd getgoingwithgradle and hit enter. At this point, we're in a new empty directory, so we can create our Gradle project. Type the command gradle init and hit enter. This initializes the Gradle setup wizard, which will ask us several questions about the project we want to create. The first question is what type of project we want: basic, application, library, or a Gradle plugin. We'll create a basic project, so type 1, then hit enter. Next, we choose Kotlin or Groovy build scripts. We're using Kotlin on this course, so type 1 and hit enter. Next, we choose a name for our project. Gradle defaults to the name of the directory we're in, which is fine, so just hit enter. Finally, it asks if we want to use new APIs and behavior. These are liable to change in future, so hit enter to accept the default no. It says build successful, so that's it. We now have a simple Gradle project called getgoingwithgradle. Let's try interacting with the project by running a Gradle task. Remember, we should always use the Gradle wrapper to run tasks, so type /gradlew help and hit enter. The first time you run this, it may take some time to download Gradle from the internet. But eventually, the help task prints some useful getting started information. It says to see a list of available tasks, run gradlew tasks. Let's try that. Type /gradlew tasks and hit enter. This prints out all the tasks we can run in our project. Because the project doesn't build anything yet, there isn't much very useful we can do. That said, it does list here the init task and the tasks task which we've just run. Just for fun, pick one of the help tasks at random and run it. I'll run /gradlew dependencies, which correctly says there are no dependencies in this project. Now let's have a look at the different files in our project that were created by Gradle. Type ls-l and hit enter. We can see the build.gradle.kts file, the main build script, the Gradle directory containing the Gradle wrapper configuration, the two Gradle wrapper scripts, and the settings.gradle.kts file. Let's have a look inside the build.gradle.kts. Type cat build.gradle.kts and hit enter. There's nothing here except a comment for now, but it's ready for us to add some build logic later on. Now let's look inside settings.gradle.kts. Type cat settings.gradle.kts and hit enter. On the last line, you can see that the name of this project has been set to Get Going with Gradle, because that's the name we selected in the Setup wizard. Let's take a look at any hidden files or directories, so type ls-la and hit enter. The files and directories starting with a dot are hidden. We've got two files, .getAttributes and .getIgnore, and a hidden directory, .gradle. As mentioned before, the .gradle directory is used internally by Gradle and shouldn't be committed into version control. The .getIgnore file has been generated automatically by Gradle. Take a look inside by typing cat space .getIgnore, then hit enter. We can see two directories being ignored, the .gradle directory we've just seen, and a build directory where your project's build outputs go, which we'll talk about later. The build directory doesn't exist yet because we haven't built anything. Because these files are in the .getIgnore file, they won't be included when we commit this project to a Git repository. Speaking of which, the last thing to do now is to commit this project into version control. We need to initialize this directory as a Git repository, so type git init and hit enter. Let's get all the files ready to be committed. Type git add dot and hit enter. Now type git status and hit enter to see what files are staged for commit. Notice that everything is going to be committed except the .getIgnore directory. Let's commit all this, so type git commit -m initialize project and hit enter. Good work, you've just created your first Gradle project. Before we finish this lesson, here's a quick summary of what you've just achieved. You've used Gradle init to initialize a basic Gradle project using the Setup wizard. Remember, the options you selected were a basic project, using the Kotlin language for the build script, using the project name from the directory name of Get Going with Gradle, and not using new APIs and behavior which may change in future. You then initialized the project as a Git repository and committed only the relevant Gradle files and directories into version control. See you in the next lesson. Welcome back, and in this lesson we're going to talk about one of the most common use cases for Gradle, which is to create a Java project. Let's first put Gradle aside and consider the most important requirements for building a Java project. You'll then see how Gradle handles each of these requirements. 1. Compile classes. In a Java project, we have Java classes, files with a .java extension, that need to be compiled into executable .class files. These .class files are then executed in our deployment environment to run our application. So our first requirement is to compile Java classes into .class files. 2. Manage resources. There may be additional resources other than Java classes that need to go into our target environment. This could be text files, images, or anything else which needs to live alongside the code. All of this needs to be properly managed. 3. Package. We need a mechanism to easily package the compiled classes and resources into a Java jar file. A jar file is just a zip file in a specific format that Java recognizes, and it's a lot easier to manage than handling directories and files. 4. Run tests. We'd like a mechanism to easily run tests alongside our code. Importantly though, the tests shouldn't be packaged into the final build artifact, as they're not required to execute the application. And 5. Define dependencies. It would be great to have a way to manage dependencies in our Java project. Rather than writing code from scratch in every project, we often pull in other libraries to help do the heavy lifting. Some popular Java libraries include Apache Commons and Spring Boot. Having a way to define all these dependencies with their versions would be super helpful. Of course, there may be other requirements with more complex projects, but this list provides a good starting point. So how can Gradle help with this? It turns out that it's extremely simple to set up a Java project with Gradle. All you have to do is apply the Java plugin, which adds all the functionality you need to meet the requirements we just covered. Remember in the introduction to Gradle lesson when we were talking about plugins in the build.gradle.kts file? Well, to apply the Java plugin, all you have to do is add an entry into the plugins section of the build.gradle.kts like this. With this plugin applied, your Gradle project gets configured in a certain way and some additional tasks become available. That's what plugins do. They add new functionality to your project. The Java plugin is one of the core Gradle plugins. That means it's important enough that it's bundled up with the Gradle distribution and maintained by the Gradle team. In the rest of this lesson, we'll look at what functionality the Java plugin brings to a project and what specific structure it expects a project to have. Our first requirement for a Java project was to compile classes. The Java plugin helps us do this through a task called compile Java. You can run this task like you would any other Gradle task with /gradlew compile Java. This task uses whatever Java installation is set up in your environment to compile your project's .java files into .class files. These .class files get output into the Gradle build directory, which is a directory where any generated build outputs from Gradle get created. Here's an example with a Java class, myFirstClass, in a com.gradlehero package. When we run the compile Java task, the .class file gets output into the build/classes directory with a similar directory structure. Don't worry about the details of the directories for now, because I'll explain the structure in full later in the lesson. What's important to remember is just that the compiled classes go into the build directory. The next requirement for a Java project was to manage resources. You guessed it, the Java plugin lets us do this through another task. The task is called process resources. You run this task using /gradlew process resources. The task looks in specific directories in your project which have been marked as resources directories and copies the contents into the build directory. The reason it's called process resources is that it can do additional processing along the way, such as finding and replacing strings. Here's an example with a text file called superimportant.txt in a resources directory. When we run the process resources task, the text file gets copied into the build directory with a similar directory structure. I'll go over the directory structure in more detail later, but just know for now that process resources copies resources into the build directory. The next requirement for a Java project was to package our compiled classes and resources into a jar file. Unsurprisingly, there's another Gradle task for this. Can you guess what it's called? That's right, the Java plugin adds a jar task, which you run using /gradlew jar. The jar task takes all the compiled classes and resources from the build directory and adds them to a jar file. The name of the jar file is projectname-version.jar. It uses the build metadata we saw earlier defined in the build.gradle.kts and settings.gradle.kts files. Here's an example of a project with classes and resources. The jar task packages them into a jar file in the build/libs directory. You can try building a jar file yourself in the next lesson, which is a practical all about creating your first Java project with Gradle. The next requirement for a Java project was to easily run tests. That's achieved with a task called test, which you run using /gradlew test. What this does is compile your test code, process any test resources, then run the tests. The other nice thing it does is produce a pretty test report in the build directory. The report tells us what's passed and what's failed. In this case, it's a 100% success rate. The final requirement we had for a Java project was to easily define dependencies. The way dependencies are managed in Gradle is in the dependencies section of build.gradle.kts, which we discussed briefly earlier. As a reminder, a dependency definition looks like this. Here we have two dependencies defined, one for Apache Commons Lang 3 and one for JUnit 5. When you define dependencies, define the group name and version, separated by a colon. This gives Gradle enough information to be able to find their dependency in whatever repositories you've configured. When you declare the dependency, it goes into a specific dependency configuration. Implementation is for dependencies required during compilation and execution of your code. Test implementation is similar, but is for dependencies required during compilation and execution of your tests. It's important you pick the correct dependency configuration because they're used to generate the Java class path. The class path is used by Java so it knows about all the classes required during code compilation and execution. When the compile Java Gradle task uses Java to compile your classes, the class path must include all the relevant dependencies. In this lesson, we've talked about how the Java plugin takes classes and resources, processes them in some way, and outputs generated files into the build directory. The last topic to cover is the default project layout that the Java plugin expects. Using this standard layout means Gradle knows where to find things. Source main Java is where the Java plugin expects to find classes. Source main resources is for resources. Source test Java is for test classes. And source test resources is for test resources. As is normally the case with Gradle, these locations are configurable, but it's always best to go with a default layout because it's the standard people expect. It's also the same layout that the popular Maven build tool uses. Let's see where the classes and resources end up in the build directory. Remember, the build directory contains all the Gradle build outputs and importantly doesn't get committed into version control. Classes go into build/classes/java/main, resources go into build/resources/main, test classes go into build/classes/java/test, and test resources go into build/resources/test. You don't need to remember all these destination details, but it should help you navigate your way around the build directory when you need to. In summary, applying the Java plugin initializes a project as a Java project. The Java plugin adds tasks for compile Java, process resources, jar, and test. Dependencies can be defined as implementation or test implementation, and they end up on the generated Java class paths. Always use a standard project layout so the Java plugin knows where to find files. This has been very theoretical up to this point, which is why in the next lesson you'll jump into a practical to create your first Java project with Gradle. See you in the next lesson. At this point in the course, you have practical experience creating a basic Gradle project and running tasks. You're also familiar with the Gradle Java plugin and the ways in which it configures a project. Now it's time to solidify all that knowledge by putting it into practice. Let's get right into it. You'll create a Gradle build for a simple Java application. If you don't have any knowledge of Java coding, that's not a problem because you'll have access to all the code you need. You just need to understand at a high level what the application does and how it's built. The application is very simple. It will take as an input a language code, such as EN for English or ES for Spanish. It will output the word hello in that language, assuming it holds a translation for it. Here are some example inputs and outputs. If we input EN for English, the application prints hello. If we input ES for Spanish, the application prints hola. I know, it's amazing stuff. This could really be a competitor for Google Translate, don't you think? You'll build on top of the project you created in the previous practical, creating your first Gradle project. If you haven't created that project, then please go back and complete that practical so you're in the right position to begin. As usual, you'll find step-by-step instructions and full code snippets below this video. We're going to start off with the project exactly as we left it in the previous practical lesson. We'll make several changes, such as editing files and creating new files and directories. If you want to do that on the command line, that's fine, or you can use a text editor or IDE you're comfortable with. I'm using VS Code as a simple text editor to browse and edit files. I won't use any IDE support for Gradle, as I want you to understand Gradle from the foundations. All the commands we run will be interacting with Gradle from the command line. So here's the project structure as we left it in the previous practical lesson. As a recap, we've got the getignored.gradle directory, the Gradle directory containing the wrapper configuration, the build.gradle.kts build script, the two Gradle wrapper scripts, and the settings.gradle.kts file where our project name is defined. We've also got the two Git files. First off, we'll add the Java code for this language application. There's main application and test code to add. But let's start with the main application code. Remember, this goes into a directory called source main Java. So let's create that structure. This is where Gradle looks for Java classes when we run the compile Java task. Create a package in here for our code with a directory structure of com/GradleHero/languageapp. Inside that new directory, create a Java class. So create a file called sayhello.java and open it for editing. Now go to the notes below, copy the contents of sayhello.java, and paste it into the file in your project. This is all the code for the application. There's a main method that takes in some arguments. The first argument, the one with index 0, is the requested language. We take this language and add a .txt to it, and look for that file in resources on the Java class path. The rest of the code opens the resource, reads it, and prints the contents of the first line. This means that you can request a language, and if there's a file present in the resources, the application will print out the contents of that file. Speaking of which, we should create some files now for the different languages. Remember that resources go in source/main/resources. Create a new directory under source/main called resources. Create a file en.txt. And inside we'll write hello with an exclamation mark for emphasis. Then create es.txt and add hola, which from my Spanish lessons I'm 99% sure means hello. This is all the code and resources we need to run this application. Now let's build it. We do that by adding the Java plugin and a few other configurations so we can compile the code, generate a jar file, and execute the application from that jar file. Close these files, go into build.gradle.kts, and delete the comment. Now let's add the plugins block, which is the word plugins with curly brackets. Inside the curly brackets, declare the Java plugin by typing Java. With this one change, we now have a lot of new functionality in our Gradle build. Go to the command line and type /gradlew tasks to see what tasks are available. All the tasks listed under Build Tasks were added to the project by the Java plugin. In the previous lesson, we talked about the compile Java and process resources tasks. You don't see them here because they actually run automatically when you run the classes task. Or in Gradle terminology, the classes task depends on the compile Java and process resources tasks. Gradle only shows you the high-level tasks by default, but you can see all tasks by running gradlew tasks --all. Under other tasks, you'll see compile Java and process resources. Let's see what happens if we run compile Java. Run /gradlew compile Java. Notice that a build directory was created. In there is a build/classes/java/main directory, and in there gets generated compile java.class files in the correct package structure. If you can see sayhello.class, then everything's working properly. Let's do the same for process resources. Run /gradlew process resources. You have a new directory, build/resources/main, containing the text files we created earlier, en.txt and es.txt. That's great. Let's now generate a jar file, so run /gradlew jar. In build/libs, you now have a jar file called getgoingwithgradle.jar. Notice there's no version included because we haven't specified a version in our build script. Now we'll try running the application using the jar file we just created. Type or copy the command java-jar build/libs/getgoingwithgradle.jar -en. This runs Java using the jar file in build/libs, passing an argument of en for English. Hit enter. You'll see an error saying no main manifest attribute. Java doesn't know what class within the jar file to run. We have to add what's called a manifest file specifying that sayhello is the main class. That's easy with the Gradle Java plugin. We can configure the jar file in the build script with this snippet of code. Paste or type it in, making sure that the class package and name matches the main class you created. This configures the jar task to also create a manifest file with this main class attribute so that Java knows that sayhello is our main class. Build the jar file again by running /gradlew jar. Now rerun the Java command that failed earlier, and you'll see the text hello output. Just to prove this works correctly, run the same command but replace en with es for Spanish. It now says hola. Awesome, you've just built your first Java application with Gradle. We're not done yet though, as we need to add a test to make sure that this powerful application behaves as expected. Tests live in source/test/java, so under source create a new directory test/java. We'll create a test for sayhello.java, so within this directory create the same package structure com/gradlehero/language app. Now add a new file sayhellotest.java. Copy the sayhellotest.java class contents from the notes below and paste it into the new file. The test class uses the JUnit testing framework that makes sure the sayhello class executes without error. Try running the test with the test Gradle task. This will compile test code, process resources, then run the test itself. Type or paste the command /gradlew test and hit enter. OK, we have an error saying it can't find the org JUnit Jupyter API package, which is the JUnit code needed to run tests. This happened because we haven't declared a dependency on this library, so when our test class is compiled, it's missing JUnit from the class path. Let's fix this by adding a dependencies configuration block to our build script after the plugins. Type or paste in the dependency configuration block from the notes. This adds a dependency to the test implementation dependency configuration, which means it will end up on the class path during test compilation. We've declared the dependency with the group package version structure for JUnit 5. We also need to add a repositories configuration so Gradle knows where to find this dependency. Type or paste the repositories configuration block from the notes, putting it just before the dependencies. This tells Gradle to use the Maven Central repository. Run the same command that failed again, and you should see a successful build. Let's double-check the test report located in build/reports/tests/test and open index.html in a browser. Sadly, you'll see that 0 tests have run. So what's going on here? Well, since JUnit version 5 is still in the process of being adopted from JUnit 4, an additional configuration is needed to enable it. Type or paste the test configuration block below the dependencies block. This configures tests to use the JUnit 5 platform. Run /gradlew test again. Refresh the page in your browser. Now you'll see one test was run with a 100% success rate. Everything's working correctly. All that's left to do is commit this project, run git add dot to get everything ready to commit, then git status, and you should see all the files we've just added and changed, so commit these by running git commit -m with a message create Java project for language app. Good work, you've just built, run and tested your first Java project with Gradle. There are some important points still left to cover, so we'll come back to this project in a later lesson to explore some other tasks like build and assemble. See you in the next lesson. Welcome back. In this lesson, you'll learn 3 key Kotlin language features to help you better understand Gradle build scripts. Kotlin is a scripting language built to run in the Java Virtual Machine, the JVM. Kotlin has some nice features that make writing code quicker than Java. Gradle uses these features to make defining your build very concise. We'll cover some more advanced features in the rest of this lesson, but here are 3 fundamental differences between Kotlin and Java. Semicolons are optional in Kotlin. Strings support interpolation by default. val is used to declare read-only variables, and var is for mutable variables, variables that you can assign another value. In Kotlin, lambda expressions are a way to pass a function around, then execute it at a later point. Here's an example with a lambda expression defined in curly brackets and assigned to a variable called lambda expression. Then it gets executed to print 321 liftoff. Lambda expressions are used heavily in the Gradle build script. For example, consider this repositories definition. Repositories is actually just a function call with a Lambda expression as an argument. The contents of the Lambda expression is Maven Central, which gets executed at a later point. In Kotlin, parentheses are normally required when calling a function. Take this Gradle dependency definition, for example. When we call the implementation function, we use parentheses to pass the dependency string argument. However, when a Lambda expression is the final argument to a function, the parentheses can be left out. To illustrate this, let's look again at the repositories example. The Lambda expression is the final argument in the call to the repositories function, so the parentheses are omitted. Why do you need to know these Kotlin language features? Isn't it enough just to know how to write a Gradle build script? That may be enough for the basics, but this knowledge will help fast-track your Gradle learning for these reasons. 1. If you use IntelliJ IDEA, you can browse the Gradle source code directly and understand what functions are available to use in the build script. This can be quicker than referring to documentation. For example, here's a function definition from one of the main Gradle interfaces called project, containing the repositories function we just looked at, and many more. All these functions can be called directly from the build script. 2. With this knowledge, you can make use of more advanced Gradle features like writing custom plugins. We don't cover these topics in this introductory course, but these fundamentals allow you to continue learning if you want to. See you in the next lesson. Welcome back. In this lesson, you'll learn in more detail what the Gradle task graph is, what it looks like in a Java project, and how you can make best use of it in your day-to-day work. We already saw in Introduction to Gradle how tasks can have dependencies on other tasks. A dependency on another task means the other task runs first. Let's use as an example some tasks added by the Java plugin. The build task depends on the assemble and check tasks. This means when you run /gradle wbuild, assemble and check run first. We haven't used these tasks yet in this course, but don't worry because in a moment you'll see them in action. The interesting thing is that the build task itself doesn't do anything when it's run. It's only there to aggregate both the assemble and check tasks together. Assemble handles building your project, including creating artifacts, such as jar files, and check handles testing your project. The build task, using task dependencies, makes sure that both assemble and check get run. That's really useful, as it means you can just run a single task, build, to build and test a whole project. That was just 3 of the tasks added by the Java plugin. There are lots more, so let's take a look at the complete task graph. Yes, there's a lot to look at here. Don't worry, as we're going to step through this bit by bit. The lines that connect a task on the left to a task to the right imply dependency on the task to the right. So, for example, build depends on check. You already have practical experience of some of these tasks, including jar, compile Java, process resources, and test. These tasks are highlighted in green, showing tasks which actually perform an action when they're run. Jar creates a jar file, compile Java compiles classes, process resources, processes resources, and test runs tests. Let's take a look at the classes task, highlighted in blue. This task doesn't perform any action itself when it runs. It just aggregates compile Java and process resources using task dependencies. So blue indicates aggregate tasks. Moving up the tree, assemble is another aggregate task, which when run causes the jar task to run, which in turn runs classes, which runs compile Java and process resources. You get the idea. Now let's focus on the tasks under the test task. You'll notice we have the same compile Java, process resources, and classes tasks. This ensures that when we run the test task, our main application code has been properly compiled and resources processed. These 3 tasks are duplicated again under compile test Java. Compile test Java itself is the task which compiles all your test code, and similarly, process test resources processes all your test resources. Above all these, we have test classes, another aggregate task which depends on compile test Java and process test resources, test which ensures that both the main code and the test code are built before running the tests themselves, and check, another aggregate task which just depends on test. Finally, at the very top level is build, an aggregate task which builds and tests everything in your project. Thankfully, you don't need to remember all this information in its entirety. We'll use a star to indicate 5 key Gradle tasks to remember, which will help when using Gradle in your day-to-day work. Build is used when you just need to build and test the whole project. Assemble and jar you can think of as equivalent, and are used when you only need to assemble the project without testing it. Check and test, which you can think of as equivalent, are used to test your code without assembling it. But why wouldn't you just run build all the time? Well, medium to large projects can take a while to build, so picking the specific Gradle task for what you need to accomplish can save time. For example, if you just need to test your code change, then you can run check rather than build. This could be quicker since check doesn't depend on the jar task, so no jar is created. Conversely, if you just need to build your project into a jar file without testing your changes, you could run the assemble task. Now let's jump back into the project as we left it in the last practical lesson to demonstrate a few of these important Gradle tasks. Before we get started, we need to run a task which we haven't talked about yet called clean. This simple task deletes the build directory. Normally, you don't run this task very often, but we'll run it now to ensure we start in a fresh state and can see how each of the other tasks changes the directory structure. So let's run /gradle wclean, and you can see now that I don't have a build directory. The first important task to run is assemble, which from the previous slide you learned will compile your code, process resources, and build a jar file. So let's run /gradle assemble. Taking a look in the newly generated build directory, we can see that we have compiled classes in classes/main, resources in resources/main, and also a jar file in the libs directory. So assemble is great for generating all your build artifacts in one go. Notice that we don't have any test reports generated as assemble doesn't run the tests. Now let's delete the build directory again by running /gradle wclean. The next important task to run is check. From the previous slide, you know that this task compiles the main code, processes the main resources, compiles test code, processes test resources, and actually runs the tests too. Let's run that with /gradle wcheck. In the build directory, we have both classes Java main and classes Java test because Gradle has compiled main and test classes. In the resources directory, we still only have main resources, but if we had any test resources, they would appear here too. We also have a reports directory containing a test report since our tests were executed. Importantly, notice we don't have a libs directory or any jar file, as the check task doesn't depend on the jar task. So check is the task to run when you just need to run the tests without assembling everything in your project. I'm going to delete the build directory once more with /gradle wclean. The final important task to try out is build, which, as you know from the previous slide, depends on the two tasks we've just run, assemble and check. Let's run /gradle wbuild. In the build directory, we can see we have main and test classes, the process resources, a jar file in the libs directory, and we have test reports showing that the tests ran. So build is the task to run when you need to assemble your whole project and run all the tests. There was a lot to take in this lesson, so here are the key takeaways. Some tasks actually perform an action, and some are just aggregate tasks. Aggregate tasks combine multiple tasks together for convenience, using task dependencies. The most important tasks added by the Java plugin are assemble and jar, which both compile code and build a jar file, check and test, which both test your code, and build, which does both an assemble and a check. You now have a clear understanding of the different tasks used by Gradle in Java projects and how they relate to each other. See you in the next lesson. Congratulations on reaching this point of the course. You now have knowledge of the Gradle fundamentals as well as practical experience in creating Gradle projects from scratch. So what now? This was an introduction to Gradle, giving you the knowledge to work with simple Java projects in your day-to-day work. To go beyond basic projects and make sure you implement Gradle effectively, I suggest you continue learning to cover these additional topics. Using other dependency configurations to build Java projects efficiently, for example compile only and runtime only. Locating and configuring tasks to get your project built and tested exactly how you want. Running Java applications from Gradle with the application plugin. Building Spring Boot projects in Gradle most effectively. The difference between building applications and libraries and what you need to do differently for each. And using the Java toolchain to ensure your code always builds consistently with the same Java version. The good news is there are plenty of resources available online to cover these topics, like those at docs.gradle.org. But if you'd like to continue learning using a step-by-step approach, then the Gradle Build Bible book helps you master building Java projects in Gradle as fast as possible. If you found this course helpful, Gradle Build Bible multiplies that by a factor of 10. Never feel intimidated by a Gradle build script again. Take back control of your Gradle build and finally get your team working more productively. Ensure your Gradle project scales with the growth of your application by implementing multi-project builds, custom tasks, and plugins. To get started, click on the Gradle Build Bible link on screen right now.